Okay, so before actually getting into the questions, let us understand what is MapReduce is. So MapReduce is the distributed computing framework. Okay, and then there are two frameworks called Classic and yarn. So you need to understand the difference between Classic and yarn, and then we will see what is the map task and reduce task. So someone have asked me the question whether I will be covering only this Q&A as per the class. So the answer is no. We will actually look more in detail. But the reason why I have framed in the form of Q&A is that not only you learn the topics, but also you will be able to answer the questions. For example, I can just demonstrate running a MapReduce job without showing you. Okay, 1 minute. So to answer that question, no. Even though I talk in the Q&A format, I will get into the details of each and every topic. And also, as I have mentioned earlier, the class will be mostly theoretical. I will cover Scoop, Spark, etc. going forward, but it will be mostly theoretical, and I will give small demos to let you understand how to program, how the commands work, how to navigate through help, all those things. Okay, then you have to practice. Unless you practice hands-on, even though if I demonstrate everything in the class, you will not be able to remember. So that's why I made it a hybrid format. So theory will be covered as part of the class in the form of Q&A or in the form of demonstrations, and then you have to practice. Okay, so that you can build the skills over time. So that's the format which I'm following. Okay, so by now the cluster might be up and running. Let me see. Yes. So let me start. Let me show you first how to submit a MapReduce job. Okay, so I'm connecting to gateway node. On the cluster. So the first question is how to run MapReduce job. Okay, so before running the MapReduce job, you need to have a jar file. The jar file will have the classes which you can execute to perform the processing. So so if you understand the MapReduce APIs, and if you start developing the MapReduce programs using Java, first you will develop the code. I will show the code also in a moment. Oh my god, again. Is it bad for everyone? Okay. Sorry for that. Don't know what is going on. I am supposed to get almost 40 Mbps. I'm paying a lot of money for this, but still it's very unstable. It's not even windy. Yeah, probably that could be the solution. See, problem is with my voice. It's not with I'm not using my laptop to connect. I'm using Skype to connect. Probably, let me see. It's a good idea. Probably I will try to use wired connection from the next class, and let's check whether it will be better. Okay, or let me try now itself. Okay, I'm going on to mute. Let me try. I don't think it's a WebEx issue. It's my internet issue. So see, this is a US number. I am using. Let me try this. Let me try to uh, connect via Ethernet port and see if it will be better. Okay, just give me a few minutes. It will take time, and then we will see whether the experience will be better. So yeah, so now our cluster might be up and running. Yeah, it is up and running. So I am connecting to the gateway node of the cluster. Okay, and then EC2. Sorry. So I'm connecting to the cluster, and the way you can run the MapReduce jobs. So as I was explaining, so first thing what you have to do as a developer is, if you want to use MapReduce to process the data, first you have to understand the business requirement, use MapReduce jobs, and build the jar file. Once the jar file is built, we have to copy the jar file to the gateway node of the cluster, or client node of the cluster, or edge node of the cluster. From there, you have to submit the jar file to process the data. So here I will be showing how to process the data with an existing jar file. How to develop the Java code and how to compile it into jar file, I will explain it later. But for now, we will try to understand the MapReduce framework. So when it comes to MapReduce, there are two components. One is framework, which executes the jobs. Another one is API, which will be used to implement the business logic. So here I am only talking about the framework which executes the job, not about the development API. Sorry, MapReduce APIs, which will be used for the development purpose. So the next slide is MapReduce programming, where we will talk about how we actually code a little bit. I will not get into too many details for MapReduce programming. I will just explain the core concepts. I will show a program, and then I will direct you to YouTube channel where you have series of videos if you want to explore MapReduce in detail. Again, MapReduce is getting highly irrelevant, but still you need to have minimum knowledge about MapReduce for different reasons. One of the reason is to crack the interview. Most of the guys will ask questions on MapReduce concepts, what is the mapper, what is the logic that needs to be implemented in mapper, what is the logic that needs to be implemented in reducer, all those things. And even though you use Spark, you use MapReduce concepts quite a bit. So understanding the concepts is highly relevant, and also to crack the interviews, you need to at least write a couple of MapReduce programs and understand different concepts to be confident in facing the interviews. But work-wise, the way industry is going, MapReduce using Java is becoming irrelevant. So there are a couple of questions. Let me take those questions. First question is there a reason to submit job only to gateway node? Yes, there is a reason. The reason is you need to have a centralized location to submit the jobs. You cannot randomly select the nodes in the cluster to submit the jobs. That is one reason. Second reason is the performance reason. I think I have explained earlier also, but I will recollect. So if you start submitting the jobs on the nodes where the data node and the node manager are running, or the masters such as name node, resource manager, etc. There could be contention between the JVMs that are created to submit the jobs and the JVMs that are created to execute the job. So even when you submit the job, there will be a JVM to support until the job is completed. So there will be contention between that JVM and other resources which are used to submit the job and to keep track the job and the job execution itself. So for that reason, we always deploy on gateway node. There are alternative ways where you can submit the jobs on the nodes of the cluster. That alternative way is Woozy. When you create the workflow, the workflows will execute on the cluster itself. So one of the node in the cluster will take care of executing the Woozy workflows. But typically, we will deploy or run the jobs only from the gateway node. Yes, Pramod, that is correct. Okay. So now I logged into the gateway node. So to submit the jobs, you don't need to develop the MapReduce code. There are examples jar files which are provided by Hadoop itself. So those are part of Hadoop distribution itself. Whether you use Cloudera or Hortonworks or even plain vanilla Hadoop, there will be a file which have Hadoop examples in them. So you need to identify the path of that Hadoop examples, and you can use that Hadoop examples.jar file to submit the MapReduce job to understand the behavior. And also, if you want to tune the performance, you can just use these examples jar files, and you can leverage these examples in many ways. Okay, so for today we will be focusing on how to submit the job by using this examples jar file. So to get the path, no matter what distribution you are using, go to use find command / typically the code will be in the all the jar files will be in the OPT or USR. So you have to search in these paths, OPT or USR, if you are using distributions such as Cloudera or Hortonworks. If it is plain vanilla Hadoop, the path might be a little bit different. If you have root access, it will be easy to run this find command. If you don't have root access, then you will be getting a lot of permission denied errors. Especially people who are using CloudX Lab, you might get into those issues. Okay. In my case, I am using root access, so I can use find / so I will not get permission denied errors. -name to search file by name. So this is a Linux or Unix command which will facilitate you to search files by name, by modified type, by type, whether directory or file, etc. So in this case, I am trying to search files by name using pattern Hadoop examples.jar. So even if there are other details before or in between Hadoop and examples or after examples, still it will be able to find the jar file. So we are using pattern to identify all the Hadoop examples jar files here, and then hit enter. Here they are under /user. So if you are trying to get the Hadoop examples jar file on CloudX Lab, make sure you specify /USR or OPT. Okay, otherwise you will get too many permission denied errors. Okay, and here you have multiple examples.jar file. Which one we should use? You can use any of any of these things, except the ones which are in Hadoop 0.20 MapReduce. Okay, the reason why you should not use this is, so this jar file is also Hadoop examples, but it uses old MapReduce APIs. So when it comes to APIs, there is a old MapReduce API and a new MapReduce API, and there is a difference in those two things. So if you want to test examples using old MapReduce API, you can use this. But that is being decommissioned and no one is using old MapReduce APIs. they are only using new MapReduce APIs, so you can just focus on this one or this one. So this is nothing but a soft link to this one. So you can use either of these things to actually submit the job. And how should we submit the job? So earlier we have seen Hadoop fs command to interact with the file system. Okay, and if you just type Hadoop and hit enter, there are several sub commands apart from fs. There is the version command which will give the version of the Hadoop. There is distcp command which will facilitate you to copy data from one HDFS one Hadoop cluster to another Hadoop cluster, so on. There are many such commands. One of the command is Hadoop jar, and if you see the description, it is used to run a jar file. So here we have to use Hadoop jar to run the MapReduce applications, and then copy the path of the jar file which you want to use. Okay, and hit enter. Here you can see that there are a bunch of applications. So here we did not run the program. We just ran Hadoop jar and the jar file. We didn't actually invoke which program to run. When you run this, it actually show all the valid program names. So these are the program names that are part of this jar file. And if you want to see what all classes that are there, program name need not be a class. Okay, I will explain to you later again. So if you actually want to see what are the contents of this jar file, you can just do jar. Okay, so jar is not accessible directly here, so I have to give the fully qualified path of jar. Typically it will be under let me get the path. So this find command is very powerful. It not only facilitates you to search files by name, you can search by name and type, and also the modified time. There are many other criteria which you can use to find files using find command. So here I want to search for a file by name jar. So type F means it will only search for the files. It will not list the directories even if there is a name with jar. Okay, so now I got the path of the jar file. If you start using this find command and other important Linux commands effectively, it can improve your productivity at least by 10 to 16%. Linux is very powerful, and on top of that, if you understand regular expressions, your productivity will be increased by at least 20-25%. Okay, anyway, that is out of context. So here I can use jar tvf. So tvf is the command which will list the files in archives such as jar, tar, etc. Okay, and then T for list, V for verbose, and I don't know about F. What F stands for. Okay, but you can just memorize that whenever you want to see the list of files in a archive files such as jar files, tar files, etc., you can use tar tvf or jar tvf. Here we are trying to get the details from the jar file, so here you have to give jar tvf and hit enter. You can see there are a bunch of classes here, but none of the classes matches these application or program names. So there is a class called program driver in this, which will actually map the class with these things. So why I am explaining this is when we actually give the Hadoop jar command to invoke a program, in this case with examples.jar, we will pass these things as parameters for the jar file, and then sorry, driver. Yeah, this is the one. So this will have the main program, and when you actually build the jars, you can make the jars as runnable jars. If people are from Java background, you will understand this. When you make the runnable jar, when you run the jar file, it will automatically run a program which is configured as runnable as part of that runnable jar. So in this case, this example driver dot class is the class which is configured to be invoked when we run this Hadoop jar command. Okay, and then it has the usage feature, wherein if you don't pass any parameter, which is nothing but the program names, which will be listed now, the usage will be displayed. The usage is it says you have to pass the valid program names to run a particular MapReduce job. So here we have a bunch of MapReduce jobs. There is a random writer and random text writer. These two programs actually generate text data for you. Okay, and don't use this in CloudX Lab, because when you run random writer, random text writer, it will try to generate 10 GB of random data per node, and they have 6 node cluster, so it will unnecessarily generate 60 GB of data, and the lab is not capable of dealing with that amount of data. So don't use these programs. I'm just explaining. I'm just covering to show how to run the MapReduce jobs. Or the best way is just to create a text file. I think I already have a text file. Or hello world.txt. Just create some text file and then hello world. And also you can actually get some text from wiki. Open any wiki page. Hadoop wiki. So I'm showing you how to run the MapReduce job from the examples by generating some text data on the fly. Okay, so I will only use this one because at the bottom there are tables and all those things. Paste it, save it and come out, and then if you recollect how to copy the file, you can use Hadoop ffs-put command. So in CloudX Lab, try to do this one, try to generate a text file on the fly and then copy this hello world.txt into whatever directory you want. Typically we'll have directory in CloudX Lab using your username here, /user/ whatever CloudX Lab account name you got. There will be a directory there, and you can copy to that directory or create subdirectories using mkdir command and copy the files to that location. Okay. Now you have hello world.txt copied, and we will run word count program from the jar file. So word count. So word count requires two parameters. One is the input path. The input path is user root hello world .txt, and output is user root. I have to give a directory which does not exist. So when we actually run the Hadoop jar command, it will create this directory and then it will run the MapReduce job. So typical behavior is you should pass the directory name which does not exist here. You cannot pass file names as output. You have to give a path which does not exist, or a directory which does not exist, and hit enter. Now it will start submitting the MapReduce job. So we are actually dealing with very small data. so it will be very fast. So what will happen is it will actually um, process the data using a map task and reduce task. So to get the details, based upon the framework, it will differ a little bit. Here we are using Yarn framework. So for when you use the Yarn framework to execute MapReduce jobs, it's just a rule. It's just the behavior. There is no logic behind that. You just have to give a non-existing directory. It's a typical behavior. If you want to change the behavior, you have to customize the logic. So Pramod have asked the question, couldn't get why it should be a non-existing directory. So it's a typical behavior. If you want, you can override that by customizing the logic. But the typical behavior is, for most of the MapReduce programs that are available online are that you have to give the output directory that does not exist. Yes, it will try to store the output in that directory. Okay. So now let me first run Hadoop ss-ls user root word count. So this is the directory name we have given, and you can see that it has created 8 files. Okay, I will explain why it has created 8 files in a moment, and you can also see the output by running the cat command word count part -r-star. So it will go through all the files in this location, and it will generate the output here. You can see the output of the word count program in those files. Okay, it will not emit the word count onto the standard out, which is terminal here. Instead, it will create to the word count information. The data that is generated as part of the word count output will be saved into files in HDFS in the directory which is specified as part of the output path. Okay, so the reason why you cannot reuse the same directory is the typical behavior of MapReduce program is the reducer which will generate these files will always start with this one part-r-00000, and it will generate as many files as the number of reducers used by that MapReduce job. So in this case, the MapReduce job have used 8 reducers, hence there are 8 files. So as there will be conflict with the names, it will not let you to pass the output path which is already existing. The typical behavior is to provide a new output directory, but you can override it by implementing the APIs of MapReduce and HDFS. Okay, so now let me show you the details about the job. So here at the command line, you can see very little information about the progress of the MapReduce job. It does not show how many mappers, it will actually show how many mappers and how many reducers have launched. Here you can see there is one map task and there are 8 reducer tasks. The reason why we have only one map task is we have only one file which is very small, which is less than 128 MB, which is block size. So typically the map tasks will be equivalent to number of blocks of a given file. So if you try to run this word count program on a 1 GB file, and if the block size is 128 MB, it will generate 8 blocks in HDFS. Okay, so the number of map tasks will be equal to number of blocks of the data that is being processed. That is the typical behavior. Again, you can change the behavior, but the typical behavior is number of map tasks will be equivalent to number of blocks of the data set we are trying to process. Here we are only processing one small file, and that is only few bytes. Let me show you the size of the file. Hadoop ss-ls user root hello world .txt. You can see the file is only 2 KB, okay, which is much less than the block size. Hence, there is only one map task. And you can see the number of reducers are 8. Okay, the reason why number of reducers are 8 is if the value that is defined as part of the parameter file. So we'll see the parameter file called mapRedsite.xml later, and that will actually control the number of reducers. Okay, in plain vanilla Hadoop, the number of reducers by default is only 1. But when you use distributions such as Cloudera or Hortonworks, they actually override that value. And the logic behind Cloudera is, I'm not sure what is the artificial intelligence they use or what is the intelligence they use to come up with this number. Even with Hortonworks also, I'm not sure. So they use their own logic to come up with this number. But for the plain vanilla Hadoop, the number of reducers is just 1. Here it is using 8. For this for this small file, 8 reducers is not very good. So you can actually override the number of reducers while executing the job to reduce the number of reducers to process this smaller data set. Anyway, those things we will differ for now. They are considered as performance tuning concepts. If you have questions around that, we will take care as part of the Q&A. But for now, we will differ. The main agenda for this question is how to run MapReduce job. And the way you can run the MapReduce job is by using Hadoop jar command. And to play with it, you can actually use the Hadoop examples jar file. And I have explained Hadoop examples jar in detail, how the programs are mapped to the classes, and the parameters will change depending upon the program you are trying to run. For example, random writer and random text writer, which will generate some random data, does not read data from HDFS. It will only run a MapReduce program, and it will just randomly generate the data. So you just need to pass the output path. You don't need to worry about input path. So based upon the type of program, the parameters will change. So you need to understand the purpose of the program. Okay. I hope everyone is clear about how to submit the MapReduce job. So now I will show how to get the details from the web interface. The reason why I'm showing this, we are actually building to the concepts to answer the next question, the difference between classic and yarn. So before understanding the difference between classic and yarn, you need to understand what is this classic and what is the yarn. Okay, I will explain that. So before doing that, let me copy the URL which is generated earlier. And here, as I am using AWS, I have to do something called SSH tunneling. Again, if you want to know what is this SSH tunneling and proxy, you have to watch the videos if you decide to go with the AWS lab. In case of CloudX lab, you have to, if it generates the URL when you run the MapReduce job, it will again generate with the similar IP address. It also looks similar. So you will have a host name which starts with IP hyphen blah 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 colon 8088. But again, these are they also use AWS, and these are private IPs. These are not accessible by external world directly. You have to configure either SSH tunneling and proxy, or you have to use public DNSs. So if you go to the CloudX lab, when you get this URL, when you run the MapReduce job, you have to go to IP mappings, get the public domain for the corresponding private IP. So if it shows like this, if it is 172, 31, 29, 153, then you have to replace with b.cloudxlab.com to access the web interfaces that are provided uh, as part of the lab. Okay. Anyway, here I can use this by enabling Foxy proxy also. Even with CloudX Lab, you can enable Foxy proxy, and then you can actually access all these things using private IPs. So, tools, I have to enable Foxy proxy here. First, we have to do SSH tunneling. When we run SSH hyphen capital N hyphen capital D 8157 port number, it's a standard port number, username at the rate of the host name, it will hang like this. So as long as it is hung, only then, till that time, the tunneling happens. Beyond that, the tunneling does not happen, and you will not be able to access anything if the tunneling is stopped by for any reason. Okay. Now we can, once the Foxy proxy is enabled, you will see this blue colored icon rotating, and then you will be able to access it. Okay. Now you can see that this job has run with 1 mapper and 8 reducers, and you can actually click on the map or reduce to see the details of the task. Click on the task, go to logs, and it will show you what have happened as part of the execution of the corresponding task. So the reason why I am explaining this is, if there is some issue with the job, so you need to see what all tasks are failed, go to the task and go to the logs of the task, and there will be exceptions right here. So this is the way you need to troubleshoot if your MapReduce jobs have failed. Okay, and now we will come back to the framework. Which framework is used to execute this? I have used Yarn framework. So Yarn framework uses components called resource manager, node manager, etc. And classic framework use job tracker and task tracker. So we need to understand the differences between these things. So I will explain in a moment. For that, I am opening another PPT. Training Hadoop. Yeah, actually it's in the research. Just give me a moment. Research, big data, code. So this presentation, what I'm showing is already in GitHub. Okay, you can go to the code repository and then Hadoop, and then there is a directory called administration. There is this Cloudera or Hortonworks. You can go to each of them, any of them, and then there is a presentation called Setup Hadoop Core Components. Okay, so in this, it has both HDFS and MapReduce and Yarn. So how to configure MapReduce and Yarn. So I will show the difference between MRV1 and MRV2. Okay. So you don't need to worry about how to configure these things as a developer, but you need to understand the different differences between the two. Okay. So the classic is also called as MRV1. So this is the framework which is originally developed with HDFS as part of the Hadoop 1. Now we are using Hadoop 2, and in that Hadoop 2 also we are using Hadoop 2.7, which means that is the latest one. But to begin with, they have started with Hadoop 1, and when they actually developed Hadoop 1, they have developed HDFS and MapReduce, and to process the to run the jobs and to execute the jobs, they have come up with this MRV1 or classic architecture. Okay, In this, there are daemon processes called job tracker and task tracker. So in my lab, which is running on AWS, I have both classic and yarn. For you, in CloudX lab, you will not see both, and it is not required also. To practice, you don't need to you need to explore both, but you just need to understand the differences. As a developer, the way you submit the jobs is by running Hadoop jar command. So it doesn't matter whether you are running the MapReduce applications against Classic or Yarn. The steps are similar. You don't need to worry about understanding the framework in detail, except for very advanced programming. Okay, where you actually play with the Yarn APIs or MapReduce APIs to tune the performance, etc. Okay, now I am connecting to my Cloudera manager. For the lab, I have for myself on AWS. Okay, I'm logging in. So once we answer this question, it will be pretty fast. Don't think that it will take forever to complete these questions. Probably by this week we will wrap up HDFS and YARN. And you can see that I have MapReduce in this Cloudera cluster. And also I have YARN. Okay, so I have configured the cluster with both the frameworks. Okay, and if you click on MapReduce and if you go to the status of Cloudera, you have job tracker and task tracker. And task trackers are the ones which are running on the nodes where we have HDFS. So this is a 7-node cluster where I have 4 nodes as slaves, and those 4 nodes are configured for data nodes and task trackers. So if I submit job using Classic, then task trackers and job trackers will take care of the job execution. Okay, and if I submit job using Yarn, then there are other AND related components which will take care of submitting the MapReduce job. So the main thing is you need to understand how this works. Okay, so I will just give me a moment. Okay, I think. Okay, so the way it will work is I have to open one more slide. Okay, just give me a moment. So planning Hadoop. Not this one. Google Drive. Hadoop. There are a couple of pictures I'm not sure where they are. Just give me a moment. I think yeah. There should be Cloudera certified administrator of Apache Hadoop. Yeah. So where is that presentation? File open recent. More. Yeah, this is the one. Yeah, now I got it. So this is the architecture of MRV1 or Classic. So there will be a job tracker, which is the master, and then task tracker, which will be running on all the nodes in the cluster. And job tracker will coordinate with the task tracker to execute map tasks and reduce tasks on wherever we have data. Okay, so what job tracker will do is it will actually submit the job, and also it will keep track of the progress of the job. And if on a very large cluster, if you are submitting too many jobs at a given point in time, and then this job tracker will become bottleneck. And Yahoo actually realized that beyond 2000 or 3000 nodes, and also if you submit too many jobs, this job tracker keep crashing regularly. And if job tracker goes down, you will not be able to submit any jobs. The reason is, if you look into this picture, it will explain how the workflow will look like. When it comes to this picture is for yarn. Similar picture should be there for MapReduce also. Anyway, I will try to explain using this itself. So what will happen is the job tracker will submit the job and try to keep track of the progress of the job, and also job tracker keeps track of the cluster also. So whether the cluster is up and running all the time or not, whether any task trackers have gone down, etc. So on a very large cluster where too many jobs are being submitted, doing both the things, resource management as well as keeping track of the jobs that are being executed, is too much for one job tracker. And if job tracker goes down, you cannot submit the jobs at all in the cluster. For that reason, as part of Hadoop 2, they have come up with a new framework called Yarn with MapReduce, or MRV2. So using Yarn, they have addressed that issue. Instead of job tracker itself submitting the jobs, for each job, what Yarn will do is it will create something called application master, and that application master will take care of the life cycle of the job. The resource manager, which is the master in Yarn. So if you go to my lab, I have both Classic as well as Yarn. So if you go to Yarn, if you click on this, in the status summary, you will see new terms called resource manager, node manager, job history server, etc. So resource manager is the master of the class for the processing using Yarn, and node manager will be running on the slaves. Again, if you click on this, on the same nodes where I have data node, node manager will be running. Typically in production, we will not have both. We will either have classic or yarn. Okay, and these are the terminology which you need to keep in mind. With yarn, you will have resource manager, node manager, and on top of that, each job will be managed by application master, and that application master will be generated on the fly. Okay, so when you submit the job, first thing it will do is it will try to create the application master, and then it will submit the job using the application master, leveraging the data locality and all those things. So this is the difference between classic and yarn. The main question which I am trying to cover is what is the difference between classic and yarn. So in case of classic, you have job tracker and task tracker. Job tracker takes care of managing the cluster and also the submission of the jobs and keeping track of the jobs. Whereas in yarn, you have resource manager and node manager. Resource manager will keep track of the cluster, whether all the node managers are up and running or not, and then submission of the jobs are decentralized and taken care by application master, and this application master might start on any node in the cluster, okay, on any of the slave node in the cluster, and both of them keep so the resource management is taken care by the masters itself in both the frameworks. In classic, job tracker takes care of the resource management. In yarn, resource manager takes care of the resource management, and the way they take care of the resource management is the slaves, which are task trackers in classic, and node managers in yarn sends heartbeat. Heartbeat is the industry standard mechanism where the slaves will actually communicate to master that they are alive and they are capable of performing tasks for their master. So even in Hadoop, whether you use classic or yarn for executing the MapReduce jobs, it uses the same concept called heartbeat. This heartbeat will be sent to masters every second, and resource manager in yarn and job tracker in classic will take care of health monitoring of the node managers or task trackers. But the execution of the jobs is done by job tracker, means the submission and keeping track of the jobs is done by job tracker in classic, whereas in yarn, before submitting the job, it will create a per job application master, and that application master will take care of keeping track of the job that is being executed by the mappers and reducers to process the data. So just understand those differences. No need to get into too many details with respect to classic and yarn. Actually, if I interview someone, I will never ask the difference between classic or yarn to a developer. For him, it is not that important, especially for the entry-level developers. Okay, but for administrators and for the architects, they need to understand the difference more in detail. Okay, so as long as you can answer this question in such a way that means if they ask differences architecturally, yarn uses resource manager as a master, node managers as slaves, and it processes data using map tasks and reduce tasks. But there will be a per job application master which keep track of the progress of the job, whereas in classic, job tracker will both do the resource management and also the job management, and task trackers with the help of mappers and reducers will actually process the data. And if they ask the advantages of yarn over classic, yarn is more generic framework where it not only works with MapReduce jobs, but it also can work with Spark, Impala, etc. And also yarn is more decentralized, and the job management is done by per job application master, which can be created on any node in the cluster. So the amount of work that needs to be done by the master is relatively low. Hence, the probability of the failure is significantly lower compared to the job tracker. So these two are the most important points which you need to explain whenever you face the questions. Okay, and now we'll go back. to this, and now we will see what is map task and reduce task. So there is a question from Chandrasekhar. Does Cloudera certification include MapReduce programs and the yarn questions? No. The new certification CCA, Cloudera Certified Associate Spark and Hadoop Developer, you don't need to worry about this at all. No MapReduce, no yarn. It is primarily Scoop, Flume, Spark with Scala, Spark with Spark with Scala and Spark with Python, and then Hive and Impala. So these 6 are the major things that are part of the Cloudera certification. You don't need to develop any MapReduce programs. Even with Spark, even using Spark with Scala, Spark with Python, they will give the code template or skeleton, and you just have to implement the Spark-based APIs based on the business requirement they ask in the question. So you don't need to be expert in Scala or Python. They will only test whether you will be able to integrate Spark-based APIs as per the business requirement in the provided code snippet to you. Okay, so you have to focus on the Spark-based APIs. Yes, you need to have some intermediate level of Scala or Python programming, but you don't need to be expert in those things. And Scala and Python are significantly easier compared to developing the Java-based MapReduce programs. Okay, so now we will see what is map task and what is reduce task. So for that you need to understand the life cycle of the MapReduce job. Let me get the tablet so that I can actually whiteboard this. Actually, we will defer for now. It's already 7:20. If you have any questions, I will take the questions and then we will wrap up for today. Okay, this one I will explain later. I think staying in the hall closer to the router is giving much stabler internet connectivity, so probably I will start using that from the next class, or I have to get a long cable to a different room so that you guys don't hear the noise of my kids. Okay, so I can take the questions. You can ask anything. These things I will cover very fast as part of the next class, because the more important stuff you need to learn is developing the applications. Okay, understanding these questions is also important to for other purposes, but once you are on the project, you should be able to learn different skills to develop end-to-end applications, starting from Scoop, Hive, Spark, etc. So there is a question: Spark with Python or Spark with Scala, which is recommended? So there is a reason why CCA certification tests both with Python and Scala. Okay, the reason is Python have certain APIs, such as if you are familiar with Python, there is SciPy, NumPy, etc. SciPy is science related Python algorithms. NumPy is mathematical related Python algorithms. So to leverage the best of the APIs that are provided by Python or Scala, okay, you should be familiar with both. In a given application, some modules might be developed in Python, some modules might be developed in Scala, and you have to be familiar with both. The reason why they are emphasizing on both are to get best of the both worlds, and also Python and Scala are strikingly similar languages. Okay, as they are strikingly similar languages, once you learn syntax and semantics using one programming language, adapting to the other one is relatively easy. So you should get familiar with both to be more marketable in the job market. And the next question is, what is the difference between MapReduce and Spark on high level? So there are two things in MapReduce. There is a concept and there is a framework. Okay, concept wise, even in Spark they use Spark and they use MapReduce concepts. Okay, using Spark APIs.
in MapReduce also you have MapReduce APIs which implement those MapReduce concepts. When it comes to framework, MapReduce execute in a different manner using a lot of I/O, and Spark uses a framework which perform these tasks in memory. So Spark is also a distributed computing framework, and MapReduce is also a distributed computing framework. But MapReduce uses a lot of I/O as part of the processing. Hence, it takes a lot more time compared to Spark, which does the distributed processing in memory. Okay, but both try to use the similar concepts in the way it is means the conceptual wise MapReduce concepts stay same whether you use MapReduce framework to execute the MapReduce application or Spark application, but the way they execute using the frameworks is different. MapReduce uses I/O significantly, Spark is in memory. Shanki have asked the question, from job perspective, how much MapReduce we should know. So if you are aiming to be a data engineer, then you don't need to learn a lot of MapReduce. If you are aiming to be an application developer, so there are applications which are developed using Mahout, and even with respect to Hadoop, even if you don't use Java, you might have to use Java elsewhere. So getting the Java knowledge might be relevant more for the application developer role. So don't think how much MapReduce we should know. Think about how much Java we should know. Okay, that is the more appropriate question. If you are aiming for the application developer, you have to know Java, you have to know Scala, you have to know Python. If you are aiming for data engineer position, you have to know Scala and Python and then you have to know the data warehousing concepts, ETL concepts, etc. Okay. So if you are a Java developer, developing MapReduce applications using MapReduce APIs will not be very tough. You just need to understand the APIs. It will take hardly a couple of weeks to master them, and I have the content already for that. I hope it answered your question, Shanti. So another question is Spark mainly for data scientists? No, it is not correct. Data scientists will hardly use Spark. Okay, there is a MLlib. So if you understand the life cycle of the project, even if it is a data science driven project, if you have to implement advanced analytics, okay, even in that case, what data science role is to understand the data points. He will say, I need data from here, I need data from there, I need data from some other place. And then it's the responsibility of the application team to get the data for him. Okay, if it is smaller data, you can give it in a spreadsheet. But if you are dealing with big data, then you have to get the data, you have to cleanse the data, you have to load the data into a model. So you have to go to the data integration framework. So that data integration framework will not be done by the data scientist. It will be delegated to application development team or the data engineers team. And these are the guys who are responsible to implement the data integration framework to get the data the way data scientists want for him to look into the insights. Okay, so it is not primarily for the data scientists. It is primarily for the data engineers and application development teams who support the data science team to get the data in the way they want, so that they can actually get the insights in the data. But that being said, Spark also provides some of the APIs where data scientists also can use. For example, MLlib. There is a Spark R, where R is the programming language data scientists use to define the model. So there is a Spark R, and also there is something called H2O. H2O is a company which provide APIs for data scientists, which runs on top of Spark. So data scientists learning Spark will get some edge to them. That being said, Spark is not mainly for data scientists. If you want to perform anything in near real time, uh, uh, any distributed processing in near real time, then you have to learn Spark. So next to Gopi's question, he asked me privately on the Java terms. Can you guide what we should learn? Yes, I will do that. We will see that as part of the next class probably. What you need to learn from the Java perspective. So Ram Kaushik Nalani, he asked the question, for achieving distributed computing in memory through Spark, do we need to have large capacity RAM? That is correct. So compared to MapReduce, it's a very good question. You are absolutely right. Compared to MapReduce based cluster, if you want to build a Spark cluster, you need to have higher amounts of memory in the cluster compared to the MapReduce based cluster, because you are using memory extensively for processing the data. Hence, the requirements for the memory will be elevated. Okay, and then Pramod have asked the question, since gateway node stages data, should it have a storage equals to the sum of storage on all the data nodes? And no, that is not correct. On gateway nodes, you have to purge the data at regular intervals. So the way it will work is, for example, you are getting 100 GB data every day, and you want to store in HDFS for 7 years. Okay, that means you will be getting 1.2 so 100 GB every day means 3 terabytes every month, which means 36 terabytes every year. And if you want to store this data in HDFS for 7 years, so 36 into 7, you need to get 220 terabytes of capacity, which means that you have to multiply with average replication factor. Let's take the average replication factor as 2.8 rather than default 3, 2.8. Then you have to have 200 into 2.8, which is 560 terabytes of capacity you need to have in HDFS. And then for the gateway node, which stages the data. So there are a couple of things which you need to keep in mind. For how long we should stage. The reason why we have to decide that is, once you roll the application, if something goes wrong, you should be able to fix the data by rerunning the jobs. Okay, so you have to define the SLAs for how long we can support that. Typically, it will be dependent upon the backups you take on the important data. For example, you will not take backup every day. You take backup probably once in a month or once in a quarter on the cluster. So let's take the example of you take the full backup every quarter. Okay, and when I say backup, it's a snapshot of the cluster every quarter. In that case, you need to have your data staged for 3 months on the gateway node. So you have to have, if it is 100 GB per day, per month it's 3 terabytes, per quarter it's 9 terabytes. So you have to have 10 terabytes of storage mounted on the gateway nodes to support whatever I have explained. So for HDFS cluster to have the 7 years worth of data, we have to get 600 terabytes. For gateway node, we just need to have 10 terabyte to support the rerunnability or reprocessing of the data in case if the data is corrupted due to bug in the code. Okay, so I will take a couple of more questions. I hope it answered your question, Pramod. So is Spark the next big thing? How are the market opportunities for it currently? So I have explained in the kickoff meeting itself. don't focus on Spark or Hadoop or any technology. Okay, try to be a data engineer or application developer. For data engineer, the technologies which you need to, which are relevant at this time, are Hive. You need to learn Hive in detail. Scoop, Spark, and also Kafka and Storm. I will not be covering as part of this class. Kafka and Storm, where you can actually perform ETL on the streaming data. All these things you need to be familiar with. And the technologies will evolve. So there is another technology called Apache NiFi, NIFI, which will actually provide a web interface for the to design the workflows for the ETL purpose, like Informatica. So there will be technologies evolving. Yeah, you might even have to work with Informatica talent. If an enterprise already has Informatica big data license, you have to work with those tools. Okay, so focus on the concepts, and then try to uh, get update with the skills over time. Some skills which are core have to be learned before have to be updated at regular intervals. But tools such as Informatica, Talent, or NiFi, you can learn once you build the core concepts. Okay, in that context, Spark is the core, like Hadoop, to which you have to learn. Once you learn, in future, even if new framework comes on top of Spark or Hadoop, you will be able to learn very quickly. And the next question is, what's the term cascade? I'm not sure. Where did you hear that? I will come back to that question, Mohan. Ram Kaushik have asked the question, while using CP command in HDFS, only file directory changes in namenode, or does blocks locations changes in HDFS? While using CP command in HDFS, only file directory changes in namenode, or does blocks locations changes? Very good question. I think it's initially immediate impact will be only the metadata will change. Metadata of the files will change. The block locations will not change. That's why CP command is pretty fast. Okay, but over time the block locations might change. The reason is, if let's say one of the data nodes goes down, the blocks have to be relocated. So the block locations will change whether you run CP command or not for a given file. But to answer your question with respect to CP command, as per my assumption, it's an assumption. I cannot confirm it. You can play with it. As per my assumption, it only changes the metadata of the file, because the CP command runs relatively very fast compared to copy from local or copy to local commands. So that's my answer. No, okay. I didn't use the term cascade. Probably you might have misheard the term. So you have to understand Hive, Scoop, Spark. I don't know. Yeah, as a big data engineer, you also need to understand one of the NoSQL databases over time. It's not immediately important, but you have to build different skills. Okay, so don't think from the perspective of a technology. Think from the perspective of the job roles which will be in demand. So the future jobs which will be in demand are software engineer. It will be evergreen. DevOps engineer, data engineer. These are the roles which are, if you look into the terms, they are very generic. They are not tagged with any technology. Okay, so I'm not sure, Mohan. I can take one more question before we wrap up for today. Sorry for the chaos in the beginning. Now I realize where the problem is. I'm sitting in a different room and my router is in a different room. That could be the reason why we are facing the issues. I think today I am talking from the hall using Wi-Fi itself, but I think the experience is a lot better to you. So I will continue doing this until I get routers in the other room. Anything else? Okay then. Thank you very much. Yeah, another question. So can we go ahead and set up Cloudera VM on Google Cloud and use its $300 free credit? Yes, but my videos does not cover how to use Google Cloud and get the virtual machine. There you will not be setting up Cloudera VM. You are actually setting up a single node cluster on Google Cloud. Okay, Cloudera VM is a misnomer. You should not use that term. You will be setting up a Hadoop cluster using Cloudera on a single node on a virtual server which is provisioned from the Google Cloud. Even in my playlist, I covered the same thing. I have used AWS. I have provisioned the EC2 instance, and then I have set up Cloudera distribution of Hadoop on that one node. Even you can use Microsoft Azure. They give $200 credit, but the $200 has to be saturated within a month. Beyond 1 month, it will not work. You have to pay money for that. I am not sure about the terms of Google Cloud. Make sure you understand the terms of Google Cloud. Most of these cloud platforms take your credit card information, and if it goes beyond 1 month, even though you don't reach $200 with Microsoft Azure, you will end up paying money. Okay then, thank you very much. See you on Saturday. I hope from next class it will be a lot smoother. Because of the chaos, even the quality have actually compromised a little bit. I will try to address this from the next class. Bye.